Animal behavior, finding food and avoiding predators. Avoiding predators and finding food are obviously two very important aspects that contribute to an animal's fitness. This is because producing offspring is going to be a lot easier when you are A. alive and B. well fed. These two things are also closely linked, because foraging for food can be risky. While foraging, you generally can't be overly vigilant for predators at the same time. So there is a trade-off between the amount of time and attention dedicated to feeding and the amount of time and attention spent staying safely away from predators. Many strategies have evolved, ensuring that animals can spend time on feeding without becoming food themselves. Prey animals can, for example, run away, play dead, let the predator know that they have seen it and that they will run or fly away if the predator attacks them. Or they might have permanent defenses, like spines or poison. They might be well camouflaged in their surroundings, or mimic another species that is very poisonous while not being poisonous itself. Another strategy is to seek safety in numbers and forage in a group. Then, there are different ways to spend your feeding time. The optimal foraging theory states that an animal should adopt a feeding behavior that maximizes its energy and nutritional intake while not being eaten itself. To maximize feeding efficiency, an animal should consider what type of food to eat. How nutritious is the food, and how difficult to find or how difficult to handle is it? If food is distributed in a patchy way, it should consider how long to stay in one food patch and when to move to the next. And it should consider how many other competitors are around in a certain feeding spot. For that last aspect, the ideal free distribution model predicts that animals should distribute themselves according to habitat quality. If a habitat is of high quality, it contains a lot of food, for example, this habitat should contain many individuals. A habitat of half the quality compared to the first one should contain half the amount of individuals. Such optimal foraging models actually predict pretty well how animals distribute themselves in nature. However, it will never predict the distribution exactly, because models like these always use assumptions that can hardly ever be met exactly in nature. For example, one of the assumptions of many such models is that all individuals have equal competitive abilities, which, in reality, is rarely the case. Strong individuals can monopolize a food source, for example, which will interfere with the distribution as predicted by the ideal free distribution model. It is good to be aware of the limits of the model assumptions, but at the same time, models are important to generate testable hypotheses and to determine factors that are likely to be important in the evolution of behavior. Experiments that allow the food intake to be measured rather accurately are able to test theoretical predictions, and these types of studies on foraging are key in understanding how selection acts on optimizing behavioral strategies.